Hello everyone, and in this video we're going to be working on multiplying rational expressions. So before we get started on the actual worksheet, we'll do a quick example just to explain the rule. Now remember, whenever we're doing fractions, you can always simplify your numerator and your denominator. So if I have 4 over 8, well, I can simplify this and divide, and this becomes 1, and then this becomes 2. So by dividing by 4, my new answer is now 1/2. This works with variables as well. If I were to have 2x over 3x squared, okay, well my exponent, I have 2 x's in the denominator, 1 in the numerator, so my exponents, my variables, would cancel out and would divide away. Now both of these are only one fraction. Don't forget, as you can maybe see in the worksheet, there are instances where you have two fractions being multiplied together. Okay. As long as the fractions being multiplied together, you can simplify the numerator and the denominator from different fractions. They don't have to be in the same one. And the reason why we can do that is simply to save on writing. I mean, this fraction to rewrite as one fraction would be a lot of work. I mean, not a lot of work, but it'd be more work than we want to do. However, I can just simplify and make my life easier, and therefore I don't have to rewrite a whole lot. Alright, so let's go ahead and do this problem real fast. So remember, we can divide away things that are the exact same off the top and the bottom, and then we can divide and simplify like we normally do. So immediately I see that my n minus 2's will divide and become 1. And then I see that I have two 8's. I have an 8 in the denominator and an 8 in the numerator. So that will divide away and become 1. And then I have a 4 and a 2. Well, 4 divided by 2, this is 2 in my numerator and 1 in my denominator. So my final answer for this is 2. Okay, because I only have a 2 in the numerator and then nothing in the denominator. Alright, let's go on to number 2. In this one, remember again, expressions, you can simplify those as long as they are the exact same. If you have leftovers, you would multiply those together. So in this problem, k plus 2 can simplify with k plus 2. And then I have k minus 7 and k minus 7. So those both divide as well. And that means I'm only left with 5 in the numerator and then k minus 3 in the denominator. So my final answer would be 5 over k minus 3. Now these next two problems down here, these are just simple examples, just to remember and remind ourselves that the old skills still work on the simple problems. Okay, in this case, number 3, my x's will cancel, and that's about it. Okay. Don't be scared of having big numbers. Don't be scared of having multiple expressions. As long as you are checking to see if anything can simplify and you are being careful with your math, then don't worry about if you have big numbers or big expressions. In this problem, things are going to look a little bit nicer. The 5's are going to cancel. The 6 and the 9 will simplify. This is a 3 on top and a 2 in the denominator, which means I have 3x over 2 as my final answer. Alright, let's get to some fun stuff. Now with these problems, we're going to go back to the first lesson, and remember, you're going to have to factor. You're going to have to factor. So for number 5, I'm going to have to factor my denominator. So I'm going to rewrite this as r minus 9, r minus 7, Alright, and there is our rewrite. So now I'm going to check to see if anything can simplify. Well, I have an r plus 3 in the numerator and an r plus 3 in the denominator. 10r will not simplify with my denominator. Okay, there's nothing else that will divide away. So then that means I'm just going to have 10r over r minus 9 and r minus 7. Okay, remember, the r in the numerator cannot simplify with either of the r's in the denominator because those in the denominator are wrapped up in subtraction, and you cannot simplify out of addition and subtraction. Now, in the last video, we talked about how you needed to combine these like terms and then put it back as a trinomial. Not always the case. There will be some problems where it wants you to put it back together all the way. There will be other problems where it doesn't mind you just leaving it as a factored expression. That will depend on the problem and on the instructions, so make sure you read carefully. Moving on to the next problem. Again, I'm going to have to factor my numerator. So I'm going to break that up as k plus 5, k plus 10, times 1 over k plus 10. And as I'm writing that, I see I have a k plus 10 in my denominator and in my numerator, which is awesome because I can simplify. And I am now left with k plus 5 over 9k. Again, you cannot simplify out of addition and subtraction, so leave that alone. Let's go on to the bottom two. Okay, so I have two trinomials and I have a binomial. So always, again, check for your two factoring. You got normal factoring and then you got GCFs. So make sure you don't forget either one. My first numerator is going to remain the same. My second one, I see how a is negative. We don't like it when a is negative, so I'm going to factor out a -1, and I'll break that up in the next step. Okay, but you always want a to be positive. Not that it affects the math, but just because we're more used to a being positive and it's easier to deal with. Okay, in my numerator I have a GCF of 2, so I'm going to factor 2 out. And then I have v minus 5 and v minus 8. Okay, now I'm going to factor my first denominator. Now, it's a good trick to look throughout your problem and see if there are any common terms in the numerator that would be convenient to match up with. So in my numerator, I have a v minus 10 and a v minus 9. So a good trick is to look at your numbers and see if either one of those numbers ends up being a factor. So I have 90 and I have 19. Lucky us, it ends up working out that way. Okay, and you're going to rewrite everything else. And then we can start to factor. So my v minus 10 can simplify, my v minus 9 will simplify, and nothing else will simplify. Do not forget about your -1. So that means I'm going to have a -2 over v minus 5 over v minus 8 as my final answer. Okay, last but not least, let's do this problem. So in my numerator, I see a GCF of 2n, so I'm going to factor out a 2n, and then that's going to give me a n plus 1. My denominator, that's going to be n plus 1, n plus 7, times, and then again, I'm going to factor out a 2n, n plus 1. Now, it is convenient, actually, in my original problem, you can see how these two terms, the numerator and the denominator, will simplify, but it's always good practice to factor out a GCF so that you don't forget about it. Okay, so that's going to simplify the whole thing with the whole thing down here. And then nothing else matches. This one is an n plus 7, and this one in the numerator is an n minus 7. So that won't go any further, which means my final answer is n minus 7 over n plus 1, n plus 7. And that is your answer. Okay, that's it for the video. If you have any questions, please let me know.